Good morning, everyone.
Good morning.
Hey, hope you're doing all right. I see the crowd in the back. The students are very early today. I hope you had a great casino night. Nice. So first of all, I'm coming from a motor city out of the US, so Germany. There are not many in Europe. One of them is in Bavaria, and I used to work in this kind of environment for some time. So being good again here in the area of another motor city here in the US. And just to make you a bit aware, so we would like to push that today as a small show and make a power breakfast out of that. So there is a competitive breakfast next to us on the other side. But you will feel the power during the day from this speech and making the SDV a bit more feasible for you guys. There will be also a small test at the end of the breakfast. So we are not testing the people on the stage, but rather you. It will be fun, no pressure. And I introduce a bit myself, maybe that helps you to get the things running. So when I was 12, I got my first PC, and being first generation migration kid coming to Germany, actually I broke it after 2 weeks. So my father had to pay the whole salary of monthly salary to repair my PC again. And since then, I promised to myself always to read before I do something with computer. And that helped me quite a bit. And actually, I continued then with testing graphic cards. So I got from all the magazines a lot of NVIDIA cards, GeForce, and tried to make the frames per second as feasible. So that was pretty fun. So I was not paid at all. I still remember that. I could keep one of the graphic cards for my setup. So I collected a lot of hardware in my basement. After that, so first time I was introduced to CUDA, by the way. So the NVIDIA hardware acceleration part as well. Then I started a band. Used to play a lot of guitar. Entered my robotics studies in the middle part of Germany. And at the end of it, I was programming in ABAP for SAP. And was pretty good job. Hourly rates were not too bad. And my first job at BMW, I remember in 2009, back in the days, BMW had around 200 software developers, real software developers, like a bit of model-based, but mainly manual code. My first job was to compare all the stacks on the market, ETAS, Electrobit, Vector, Mentor Graphics, and do a ranking. So I did the runtime behavior of the stack and making it work, and the configuration part, the tooling. Brought that back to my management, and actually it was helpful for the whole organization just to make the 80 to, back in the days it was like 10, 15 big ECUs in BMWs. Nowadays we have like 150, up to 150 ECUs with diagnostic addresses. So I wrote code after that in inverter. So some of the BMWs you might drive having ASLD code running. I'm still proud of that. And after that, one of my mentors called me and said, hey, I'm doing, I like to give over AUTOSAR to you. So I did the chairperson for 3 years. I was running the organization, extending it to 360 partners. My network was growing. And I did like moderations like that quite some time, and all in all, the big skepticism in the room was always against adaptive AUTOSAR. You might hear it. There's classic and adaptive AUTOSAR. Adaptive is meanwhile all the OEMs, like the premium OEM cars, one of the platforms we are running. And at the end, it became boring in BMW. I became director for 20 people. And more politics came in, big organization. So I moved to the Silicon Valley, and with my family and everything. So I'm pretty much West. I think Atul and I are the only Californian representatives within like TTL, within Tata Technologies. And I'm chasing technology. So I'm a technology person. I usually speak on more technical conferences and would like to bring you the idea of what it means to lead maybe in this kind of times, that people like in the back left side are entering your organization and actually stay there, right? Like to work in your software-driven organization. I did 2 startups before I came to TTL. The last one was a LiDAR company. It was competitor to Aaron. We spoke recently about Luminar against EVA. So it's a pretty interesting space right now. And right now I'm responsible for the whole SDV movement, I would say, as part of the big Tata group. And I would start with a small presentation about the group itself. But don't be scared. The numbers are only numbers on the slides. So as said, Rinat, I also will bring in some of my colleagues and friends here on the right side. And we will give you a package of what software-defined means in future. And not only speaking about how this transition could work, but actually giving you some hints to implement that in your organization. So the Tata Group was founded in 1968 and 150 billion revenue. We have almost 1 million employees. All in all, I think there's 1,10 to less, and it's a huge brand within India. So it's always saying like if Tata is going down a bit, so India is going down. So it's always a connection. And out of the history, there's a strong culture in engineering in that. And actually, the whole company is built between salt and software. The complexity is pretty increasing to the software area. And one of the subsidiaries, which is TCS, has around 600,000 engineers roundabout. Let's continue with Tata Technologies. We are standing next to the OEM and solving, in fact, the problems of your daily work. Is it in vehicle integration, in software integration, or making the future technology happen? And we will today focus on topics around the electrical powertrain integration, but also providing to you a platform where Nigel will speak about later. And we have that also as part of some verticals. So we have the verticals in automotive, industrial heavy machinery, leading aerospace, but also as a tier 1 next to a tier 1 implementer. 11 legal entities all over the globe. As soon we need an OEM interaction, we are standing next to them and helping them with the problems. The verticals are very strong integrated within the organization with partnerships and accelerators on the lower part. And we actually look then on topics like SDV, Gen AI, ADAS, systems engineering, which are more cross-cutting over all verticals. And so the customer space is coming from the 3 columns, in fact. So I think that's enough for the general introduction. Everything else we can also do in a small one-on-one, or I would like to shift a bit to the software area. And some of you are coming from that, or some of you have to look over it. And this slide is in fact showing on the upper part the history of software engineering, and on the lower part, the automotive industry, and how it is perceived and implemented, utilized within the automotive industry with several standards. So if you look back in 1964, there was something like a software engineering general idea started here. There was a first conference coming up, and not too far from this location here, first institutes were gaining experience within software engineering. We were coming down to design patterns and UML, agile manifests, and DevOps. So this was already almost 2010s. So within 30, 40 years, this industry was growing. And these are people that are in general comfortable sitting on or standing on their desk and coding the whole day, or the time they can spend and concentrate on that. The time where it's automated, they usually play table tennis or just hang around doing some coffee, right? So it's a pretty relaxed culture because the other part of their daily life is a very focused one with the newest technologies. What connects us today is the programming languages. Who knows which kind of programming languages are running in our cars? Ken, I rely on you on that. Any guess? Like out of this space, give the others a chance as well. Rust is one of them, it will come in, but there are two languages here which are actually already now in our cars. There's someone was saying C++, one, and then we leave out the plus, and there is only C left, right? So C and CC had the strongest compilers, also in the sense of memory safety. So it became a very interesting language from the early days to be implemented, especially by MISRA. So you know the MISRA coding guidelines. Since then, there is a safety standard, including medical care and industrial automation was created. And out of that, 2003, AUTOSAR was growing up. Specification for platforms, process standardization, first functional safety standards, first cybersecurity standard, first SOTIF standard, which is important for automated driving, Aaron would agree. And then we have, again, cybersecurity and update recently. So in fact, every OEM in Europe cannot kind of release any car without having the cybersecurity homologated as of last year. And with that, we have first cars, which is kind of a bit of a merge. First cars implemented in San Francisco, where we understand automated driving in a complete different way. So I was standing in San Francisco after watching an opera, a German opera in San Francisco. We were walking out, and there was on the street, left side, free robotaxis, and we had the option for free taxis. We took the taxis because the robotaxis didn't extend to the East Bay. So you have to pass the East Bay Bridge, and it was not part of the area. But actually, it's the same experience right now. If you go to San Francisco, go for it, try it. Yeah, looking to that, so there is quite a merge, and the bottom line of this slide is our goal as an industry here is to make our organizations as attractive as possible to get these resources. Because these resources would by nature not join our organizations. They would join a startup or a big tech company. I hope you don't listen too closely, this corner there. Thank you. So let's continue with the next slide. And I give you just some numbers before we come to the real content, including my colleagues over. So we have the business IT left side. And if you look to the code amount we're dealing with in 2030, with an estimate of 300 million, and generated code within an automated driving car of around 1 billion, which is a half of a search engine in a data center, you can imagine with the safety implication, the cybersecurity implication, what we are really dealing with. It's a bit of a monster, but for software engineering, it's quite interesting. And click. I also give you by hand the only definition that I found so far for SDV. Everything else is just a company-driven interpretation, because everybody is using SDV for its own purpose. business purpose partly. So the fragments of an SDV has a strong relation of software, which means it's realized. The big functions and features, services are realized by software and continuously updated over lifetime and between the vehicles and the cloud. So you have your whole fleet. So we have the aspect of your software your organization needs to be software driven. You have the updates, the software parts and the features. And in addition, the development must be accelerated through things like digital twin, virtualization, and exists in a digital reference over the lifetime. So it's the life cycle 10 plus 15 years, 15 plus 10 years, depends on the OEM. And fun fact as well, if you look to a non-software driven company, they speak about it. If you speak about companies like Google, also the startups today, they usually don't even mention the phrase SDV. So most companies out of the valley, they're just driving software and kind of deploying it, but not speaking about that, right? So you can identify that quite simply. If company is speaking about it, then it's more a mechanical driven, or out of the history, maybe a mechatronical driven company. And we need to do this transition kind of within it. Very simplified, but I think it's important to understand. And I switched to the year, so let's do a future of time like 2029. We are right now in 2024. So everyone who's dealing right now with architecture might release your car in 2025, 26. We're jumping with 3-year cycles, which is the new life cycle of cars. I know that in this room, sometimes 5, 7 years are discussed, but in fact, in software-driven world, a car should be ready in 2 years, 3 years, a bit more, maybe. We have the cloud connection, we have a gateway, we have the zonal, where a lot of ASIL decode is running. ASIL is always a high software integrity level. And then you have the more compute on the ADAS and infotainment. And there are some variants in the market for this kind of architecture, this part. If we jump 3 years further, and that might be already a bit too future-driven, we speak about central compute. If you hear your word central compute, it means that we only deal with 2 big platforms where software development is free to go. You have as less dependencies to hardware as possible, which is fantastic. You have technologies around Docker, virtualization running, and in fact, for the whole stack, what we are doing at TTL, we're starting with ecosystems, connecting to them, especially open source driven, open platforms, open solutions as well. And in fact, you need something for ADAS, something like ASAM, OpenX standards. You have Covesa with VSS, SOFI containerization, with a virtual IDEA, driven by ARM as of now. And we have AUTOSAR as a middleware, in fact. The collaboration model in this one, and you remember out of the past, there was always application software, basic software, in the middle was an RTE, right? So this was the classic architecture we were dealing with. It's moving more and more to the hardware corner. So the red line here is in fact the OEMs, which are approaching today less the tier ones, but more the silicon supplier to make the project work. So every HPC starts with a call of an OEM to get the newest silicon and most compute in their car. And with that, a lot of software partners are needed to make the software stack feasible. So in BMW right now, the software community is around 3,000, I would say, people working on in-vehicle software. And one of the early projects had a size of 1,000 engineers, 150 feature teams, and around 15 software partners within this organization. This picture is quite messy, but Steve likes it, so we could speak like for an hour on this one. But in fact, it shows for you the cloud, an AWS pipeline, an implementation stitched together open technologies. And we kind of collaborate with Eclipse SDV. We have Covesa parts, we have Autosar parts, we have Sophie, a Linux below. And we use that as a reference platform, as a starting point for a lot of OEMs. And usually the OEMs are replacing some parts of it, and then we're ready to go. So always take a pre-integrated step of such an image and make it work with some demonstration. We have here an instrument cluster and some updates running on the right side. Okay, so, and here the magic happens. You have here as well some ML. SageMaker I saw a couple times already here around this technology. But you can also work here with Databricks or something else here in this corner. And we do here a lot of validation, verification as well, based on the AWS instance. In fact, we're skipping the A and B sample with that in a lot of projects. So it becomes condensed from the timeline's perspective, but also needed, this timeline. The proposition, what we are starting with usually is in green. We are experts out of function safety. We are born out of that. Have a lot of projects with companies, I always tell 3, Volvo, Stellantis, JLR. And then looking to application software, basic software integration, test validation is important. And then the new age with software-defined support, also helping with first proof of concepts. Okay. And so the test is in fact not about this content, so I hope you're still awake, and it was a bit of, of deep dive now. And actually we were part of some projects already with vehicle context, vehicle integration. For VinFast we did almost the whole development and design and just brought it over to production sites. And also others like the JLR clarification, NEO. That's why we will also announce today, or yesterday we did that actually. And a friend of mine is coming up now to the stage. I will hand over to Nigel from the UK. We actually took the private jet to bring him over. His timeline was so hard to catch. And yeah, you have here the clicker.
Thank you very much.
Yeah, go ahead.
The private jet was stuck in Chicago for 8 hours. Yeah. United Airlines private jet. It was wonderful. Yeah. Good morning. Thank you for the introduction. Quite a surreal experience being here, actually. The last time I was here, my son was about 6 months old, and he goes to university next week. So it was 19 years ago was the last time I was here. So it's good to be back. A quick introduction about myself. I left high school when I was about 15 years old, wandered into the world not really knowing what to do. And fortunately someone said, well, you're good at art and technology, and you like cars, you like technical drawing, why don't you become a draftsman? So I did. I got an apprenticeship at Ford Motor Company. 4 years later, I promptly left. Did about 17 years of freelancing, Germany, Sweden, United States, Italy. And in 1996, joined a company called DEX, which became a company called Incat, which became a company called Tata Technologies. So I've been with Tata Technologies for about 29 years. Spent 20 of them based in the northern suburbs of Detroit, working with the likes of General Motors, Chrysler, and Ford. And 12 years ago, in support of emerging Jaguar Land Rover business that we were doing, I crossed the Atlantic 38 times in 2011, so thought it best that I just moved back to the UK, which is what I did. And my backside doesn't look like an aeroplane seat anymore, fortunately. So today I wanted to talk to you about a specific product that we're bringing to market called EVMP. An EVMP basically was born out of a high-level business challenge that we are reminded of with every customer we approach, given that an awful lot of our customers are now startups with aspirations to get into the automotive market, and they're overriding objective always is the same amongst all of them. I want to do it quickly and I want to do it cheaply. It's a common reform that we get. So to develop an entirely new platform can take in the region of 36 months plus. That's very typical. If one was to start from a clean sheet of paper, at least 3 years to get that vehicle into the market. But what we've done is by implementing EVMP here, you can see we got down to 31 months on a program that we have just delivered in the Asia market. That is now running down the vehicle production line at the rate of 10,000 a month. And we took that from clean sheet of paper to that condition in 31 months using a product called EVMP1, our first attempt at starting a program with an existing platform of our design. We now believe that with EVMP2 and all the improvements we've put into that we can now realise our initial ambition of reducing product timelines by in the region of 9 months, 6 to 9 months. So what is EVMP? I will jump past this slide and jump straight to this one. I'm only going to talk to it. I'm not even going to look at the slide. EVMP is now an existing digital platform, a fully developed platform. Underbody, structure, electrical, battery, high voltage systems. It has got all the chassis and all the powertrain all included. You see, if you visit our booth downstairs, you'll see we've got a little 1/4, I think 1/8 model that shows you what it is. But that digital model allows us not to start a project with a customer with a clean sheet of paper, but to start with a digital product that is about 6 months down the line already. Okay? It is adaptable in terms of several mechanisms. It's adaptable in its architecture, so we can breathe the vehicle in wheelbase and track and occupant positions. So we're actually morphing the physical size of the vehicle. It's also adaptable in terms of as the vehicle gets bigger and invariably heavier, the attributes of a lot of the commodities need to change. So it now can adapt from a McPherson front suspension to a double wishbone front suspension. It can uprate and adapt from a trailing arm suspension in the rear to a multi-link suspension in the rear. So very, very quickly, we're able not only to start a program in a far more advanced state, but we're in a position to cycle the iterations on that digital product much faster because of the intelligent way in which it's been built. Okay? The materials and processes that are within EVMP are of a world-class nature in line with where the industry is. So for instance, all the body structure is multi-material, everything from mild steels all the way up to ultra-high strength borons. And we've also just recently, and it can be seen in the model downstairs, we've actually started to implement and look at mega castings. So the EVMP2 includes a mega casting in the rear as well. That encompasses the rear floor and rear wheelhouse assemblies. So that's about all I've got to present on it. Again, it's an existing product. It's there available for any OEMs or particularly startups who do have aspirations to get into the product development business. TTL, Tata Technologies, can offer the market this product to give them a head start that, again, we believe saves as much as 6 months in the full timeline to market. Okay? With that, I'll turn over. Thank you.
Thank you. Thanks, Nigel. So the private jet was worth it. I mean, and if you could continue clapping, because it's always good, like power breakfast, to speed up. And especially clapping for 3 people in this room, which made our participation much easier, also with the booth. I mean, we have one of the best and biggest booths from my perspective. So Sachet, and Riz sitting in the middle. Thank you so much. So let's continue with the next slide. And there's still EVMP, so we can share the slides as well afterwards. We are switching now from the car perspective, how to get to a car. So in fact, the whole production line needs to be also more digital. And our expert working with me together in California is Atul. Please come up. Enjoy.
Hello, good morning, everyone. I hope you are still awake. I know it's almost an hour you are here. I will keep it brief. So my name is Atul Kadam. I'm working with Tata Technologies for last 25 years. Unlike Renath, I started working with Tata Technologies as my first job, and I'm still with Tata Technologies. This will prove how the Tata Technologies basically give opportunities to the talent in the different areas. And I was fortunate enough to start my career with as a software developer, and then move to the ladder, from software development to visualization in automotive to PLM, and now I'm managing the digital practice across the different verticals like automotive, aerospace, as well as industrial heavy machinery, and support customers on the digital transformation journey. Now, in the beginning, what Renath and Nigel talked about was mainly around how to create your product, right? Bringing the engineering to create your virtual product. The capabilities in terms of shortening the vehicle timelines, bringing the SDV, bringing the new technology, new material, ensuring that the engineering is done in a way that we still achieve the sustainability goals in terms of carbon reduction. Now, once we have that, another line of business at Tata Technologies, how do you realize that virtual product into a physical reality, right? Or physical product. So enabling from the virtual to a real product, that is what my group in terms of digital supports. Now, if you look at the slide, this is again a high level overview. For any product, right, there are typically we call it the 5 phases: product definition, engineering, manufacturing, operation, and sales. So across all the phases, what we do is basically we enable to creation of physical product through the different enterprise application. For example, PLM, MES, ERP. So these are the typical 3 pillars of any organization to ensure that there is a smooth transition from virtual product to physical product. We call it as a Holy Trinity. And what we support is implementation of those tools in a way that you can get the products to the market very fast, right? Now, PLM, as many of you know, is the products like Dassault's 3D experience, whether it is a Siemens Teamcenter or PTC's Windchill. So we are product agnostic, but we help customers to implement that and ensure nowadays the PLM becomes a single source of truth. What we have seen earlier in OEMs, tier ones, decade-olds having a lot of legacy systems, there is the source of truth lies in different systems, right? So we enable them to bring that to PLM, and PLM becomes the single source of truth, whether it is the engineering data or manufacturing data. Then digital manufacturing. Now, you might have seen that in the olden days, there is an engineering department, there is a manufacturing department, and there is a manufacturing execution department. All work in silos. Engineering will do the design, throw off to manufacturing to figure it out. Oh, what is my assembly sequence? Does this part fit? Do we need to change any tolerances? And that has also led to increase in timelines. So at Tata Technologies, what we do, we basically support organizations to do the concurrent engineering, wherein the engineering and manufacturing can work together so that the product which is getting designed itself, there is no back and forth between engineering and manufacturing, right? And then basically that helps to reduce the gap between engineering and manufacturing. We do a lot of support in terms of simulation so that the number of physical prototypes required are less. One of the key messages I would like to give from here is basically with this implementation of Holy Trinity, integrating the applications digitally. We establish the traceability, single source of truth across the different application. Now everybody talks about the single source of truth, but when we by the integration, but what we say that you should not integrate the application only for the single source of truth. You should be able to take out the data analytics out of it, and all the decisions to make any changes, make any improvements should be data driven. And that is where we basically support through the data analytics and the different tools and technologies for that. Okay, so in terms of reimagining the digital for the software-defined vehicles, right? So what we offer when it comes to the engineering side, SDV is typically looked only from the you have to develop some software within the vehicle. But just by developing the software within the vehicle, your organization doesn't become the ready for a software-defined vehicle. You need to have your software stack developed, integrated across the value chain of your product development. And that's where to accelerate SDV, we have a model-based system engineering. So we support from the engineering point of view as well as from the application point of view, deploying the different applications, integrating that through the model-based system engineering. We have developed our own AI ML platform tools to accelerate the engineering design as well as the accelerate on the manufacturing side for the operations. Okay. Yeah. So again, this is a little busy slide, but how do we do the your factory as a smart factory, right? Everybody talks about the smart factory or industry 4.0. But in our view, you cannot have your factory, you cannot make your factory smart if you have a siloed system. Now in this slide, you will see that we have overall around 22 to 25 solution areas. And when we say that, the factory is smart, basically we enable that through the integration to ensure that the ERP, PLM, MES, and your MOM, manufacturing operations, are integrated, and there is always a close feedback loop in terms of getting data. So we operate not only for the OEMs or the brownfield implementation, but we also do the manufacturing MES implementation for the startup organization. Now, what makes us unique is in last 30 years, we have been working with legacy OEMs, tier 1 suppliers, as well as startups. Now, we know that for the startup organization, agility is the key. Whereas for OEM, they are very process-centric. Now, since working with both the organizations, we are able to blend the agility with the process so that we can enable get the products faster to the market. And with the AI ML, we have been deploying AI ML for OEMs for last almost 8 to 10 years. While the AI or Gen AI buzzwords have started in last 1 or 2 years, we have been deploying that. Specifically, I have one slide to showcase what are the different use cases we have deployed. But with this smart manufacturing, there are a lot of industry challenges which we are trying to overcome. Specifically, with the legacy application, as I said, it's an open loop, so there is no closed loop feedback. With the legacy, there is a rigid material handling, right? Because of that, we have seen a delay in getting the product. Then there are inventory problems. So how do we automate that? We have seen the problems specifically since pandemic about the skilled workers. So how do we ensure that the new workforce gets trained faster and then still we maintain the quality? Now, while having those challenges, we also know that at the manufacturing area, there are a lot of KPIs. KPIs every time they want to improve the cycle time. They want to improve the plant consumption, reduce the energy utilization, and also make your manufacturing or engineering facility as from the sustainability point of view and reduce the carbon footprint. We want to ensure there is a real-time monitoring so that the decisions can be taken faster. Because as you know, unlike a few years back, the product is getting complex. The market demand or the customer demands, they want a personalized product, so the number of configuration changes. So your system, your operations should be flexible enough so that you can take the real-time monitoring and you can take the real-time action to ensure your throughput is as much possible, right? So with the solutions, what we were able to achieve, just to give numbers, and then maybe you can stop by our booth and I can explain about the case studies and all the different accelerators. But with these accelerators, we were able to reduce or improve the MTTR, MTBF by 15 to 25%. Improvement in the production planning, specifically by using the digital twin on the manufacturing side by 20 to 30%. Reduction in plant commissioning by 20 to 40%. So these are just some numbers to give the perspective, how do we support different customers to improve their journey. I was just talking about the AI. So this is again one glimpse that, okay, across the different phases of your product development life cycle between engineering, manufacturing, and even aftermarket, we have developed the AI solutions and deployed it to the customer. Just to give an example that we developed a AI framework for weld fatigue. Now for those who have been working in engineering, they know that like for every analysis, when it comes to CAE, it takes a lot of time. You need to run it multiple times. But we have developed the models which will predict whether the model will pass the weld analysis or not upfront. Okay, I think I'm on time, but just the last thing. So this is our vision in terms of where the world is going. Is basically AI-enabled digital factory. That is our future view. So at Tata Technologies, we are working, enabling customers to this view. Okay, so this is just a brief. Maybe you guys can stop by our booth and I can have more discussion on that. Okay, I think I will skip this.
Fantastic. Thank you so much.
Thank you.
And I like the details. Actually, like if you come from engineering, it's all about that. With that said, we're shifting the focus again to software, right? So software tests specifically. We have a strong partner with us, Keysight. And Steve, please come up. So Steve has a lot of strength beside the testing, and he can tell you, I think, in person. But we are looking now to automation, Steve, right?
Yes.
And now, stage is yours. Go ahead.
Thank you. Thank you, everybody. What a fine group of people I'm working with. I'm very proud. I also want to start by saying, you know, as I'm speaking, you're probably saying, oh, he doesn't have a British accent or a Swiss or a German accent. So I want to start by apologizing. I'm sorry, I'm from New Jersey. So with that being said, my name is Steve Barretto. I've been in information technology for well over 35 years. And I'm an evangelist on end user experience, AI, machine learning. And I'm not gonna lie, some of those buzzwords are actually my least favorite words. You know, what is AI and what is testing? Testing means a lot of different things to people. So I'm in the software division of Keysight called Eggplant Software. So exactly what is Eggplant? So Eggplant was founded in 2008, and it is a software automation testing solution, but it's very unique. It is a paradigm shift compared to every other software automation testing tool out there. Leader in experience optimization. I'm going to get into that word, experience. With global offices at that time, Keysight acquired Eggplant Software in 2020. So Keysight, to give you a sense of, if you're not familiar with who Keysight is, we have the DNA of Bill Hewlett and Dave Packard. And in the 90s, HP spun off the medical products and testing equipment spun that off, called it Agilent Technologies, and then later on spun off again where the testing equipment, Keysight Technology. Now, as I said before, one of the things I preach about is testing and automation, 2 words, very broad and loosely used. So what exactly does that mean? So I wanted to bring up the OSI stack to give you a sense of what we test. So Keysight, prior to acquiring Eggplant, would automate the first 5 layers of the OSI stack with a variety of equipment. And by the way, 29 of the top 30 tech companies are our customers. And we're a $5.5 billion revenue, $23 billion cap with 150 locations worldwide and 23 R&D sites. So we have a lot of equipment, hardware equipment used to do this specialized testing. But they didn't have anything to help automate and test the presentation of the application layer, and that's why they acquired Eggplant. So with Eggplant software, Keysight is able to automate the entire stack. Now, I said a word earlier about experience, and I'm an evangelist on EUX, end user experience. End user experience is about what a person observes and feels when using a product. All of this equipment is all important. None of it should be dismissed. Got equipment for LiDAR testing, equipment for network and security testing. I go on and on. But us end users, when we purchase a product, we either have a positive or negative user adoption on using that product. So I have a 3-minute video, but please come to the table where Tata Technology is, and I'd be more than happy to give you a live demo of what end user experience testing is all about. I think I have to press green button one more time. Yes, okay. So this 3-minute snippet, Eggplant uses automation, intelligence, and machine learning, and I have a car HMI here. This is not a simulation. This is an actual device that Eggplant is connected to so Eggplant can see it. And I trained Eggplant to go through various device settings and verifying toggle switches. Here, this is an interesting point. Testers sometimes can be their own demise. They step on each other's toes. So here I actually told Eggplant to pause it because Eggplant read what's SIM slot 1 and SIM slot 2. And it read the values on the UI just like us humans would and stored it in its memory. Because I've seen too many times testers would say, wait, my test failed. Who swapped out these SIM slots? As an example. So Eggplant can read it and verify it. Verify how? Well, do you have an Excel spreadsheet? Do you have those values in a database? Eggplant can read that as well. Whatever a person can do, Eggplant can do. So, and that's an example here of doing this directed test case. And a directed test case reflects a tester testing what he or she knows. Hold that thought on it, what a directed test case is. So now I'm going to continue in this demo video by pressing continue to play. And what Eggplant is going to do now, like an end user, is going to invoke the GPS. And if you notice, the navigation icon moved to the side. Because I trained Eggplant. When I used the GPS, that navigation icon was a pain in the butt. It's always in my way. So I trained Eggplant, move it out of the way so you can use it. Eggplant's your digital tester. So I trained Eggplant to bring up one of my favorite family vacation resorts. And then from here, it starts the GPS. Now with the Keysight equipment, I can use the Keysight equipment to generate various GPS signals, cell signals to further test the additional features of that radio. Now, this is a small snippet. The automation intelligence comes into play where testers test what they know. I encourage you to run your directed test cases, test what you know, but as you're doing that, Eggplant is taking a step back and saying, okay, I see you testing this, I see you testing this. Oh, well, you haven't tested this yet. So with the automation intelligence and the exploratory testing, this model in which represents end user journeys of using this car HMI, 66 user paths have been tested. There's 11,000 user journeys that Eggplant has calculated. So when I meet testing teams around the world and I ask them how many test cases you have, 1,500, 2,000, 3,000, proud and rightfully so. So I ask them this simple question. So can you assure that all of your test cases, you've reached 100% test coverage and uncover all of those user journeys? 99.9% of the times, the answer I get is a pause, and then I get, we don't know. We don't think we've even skimmed the surface. So with the automation intelligence and the machine learning of image recognition, text awareness, Eggplant is able to uncover all these journeys. It's not running in a random fashion. Its goal is to reach 100% test coverage. One of the things people ask me, well, that's great, Steve, that Eggplant can test the car HMI, but there's other things outside of the car HMI, like the dashboard. So how is Eggplant able to see that? Oh, that's easy. I hook up a web camera to the headset. So us humans, we see, and when we see engine light or something else, we respond, we know. So Eggplant can see it, and you train Eggplant as your digital test on, all right, so if this comes on, what do you want to do? So in conclusion, 4 important points about Keysight Eggplant's approach to end-user experience testing is that we are technology agnostic. That's the important thing about end-user experience. When you approach an ATM, or when you get into a car and does this work with iPhone? Because I don't do Android. The point is, you don't care about, as an end user, what the technology is. You just want it to work. You want it to be a fast performance. You want to have an omni-channel experience. We all have an omni-channel experience. You can see how much charge your car has from your watch or from your phone. So we are technology agnostic. We're device agnostic. That's another important point on why we're a paradigm shift, because all those other software automation testing tools that I touched on, they all focus on technology, or they focus on a specific device. We're non-invasive. That car HMI, I didn't install an agent on it. Eggplant's looking at it just like you and I would, and is recognizing images and reading text the way you and I would, and able to do end-to-end testing. I'm proud, Keysight is proud to work side by side with Tata Technologies. I hope this was a good use of your time. Thank you.
Thanks, man. That's a great thing about testing, Steve, is always as functional developer or application developer, you better, like people like Steve, you include very early in your project, because if you don't speak to them, they will just make a mess out of your whole code afterwards in testing. It's just a painful thing. And looking to the last slides, and thanks for the attention until now, I think we also want to be in time to what's happening at 9, German thing, always time boxing. So I'd like to give you a bit of a future outside what we are looking into right now, because it is important that we as an industry are solving problems which are not solved yet. And I repeat that slowly, because we are human beings, and usually we start with something we already know and just adapt that. So on the car side, we see a strong movement in the area of safe machine learning. And in the Berkeley area, there are very nice activities going on around RISC-V, about safe ML, and also about topics out of the past, like something like the Unix kernel was born there with the BSD license. Apple forked out of that, Google forked out of that. So in fact, we are in the epicentrum in the Silicon Valley of defining that. Things like the HPC, the hardware acceleration part, will become more important. Things like GPU and CPU architectures working together in an SoC, to accelerate that in the backend, but also in our cars, will be a major thing of software developers of the future. We will think of chiplets in the next 2 generations, right? So our hardware will become more modular. We will have a distribution and maintainer model within Linux running in our cars, not only in infotainment in the future. And the last part, our charging data, or in fact our e-mobility data, will be more accessible. So our charging infrastructure must become more secure. And we spoke also with colleagues from upstream about that on Monday. We need to get this external hardware in a very quality-driven, systematic way approved. On the backend side, in fact, we have fleet management, which becomes more important. Cybersecurity, it's a whole life cycle within the whole organization, have cryptographic keys running. And the virtualization will accelerate our way we develop with hardware. And the last but not least, I would say automated driving, as we said already, it is part of our daily business, our pleasure as well. And this is our proof of concept. We invite you to work with us on that. And please don't reintegrate the platform or redevelop the platform which is already existing, because this is something what everybody does, and it's not magic at all, right? So, and I give you a bit to the road some of the recommendations I experienced out of my last SDV-driven organizations, and I shortly elaborate of each point. So, if you see a small spot of people working on software efficiently and it helps your organization, create an island for them, because the culture they're driving will help your company to drive a culture to make it more future-driven and understand the programming languages which we need in our cars. Partner with companies that are already on this path, that are coming from the other side. And we see that in the Valley a lot right now. All the Detroit-driven companies are building locations connecting to these companies in the Valley. But also in Munich, you have all the big players in the center of, next to the Marienplatz, kind of with offices around that. So there is a strong connection already between software engineering in general and the automotive world. What I mean with all-level product contribution was out of the startup I was before, and actually the VP of engineering was sitting next to me and coding in the same repository as I did. Like I was director responsible for cybersecurity and functional safety, and we were working on the same code base. He knew about the product, and that was beautiful, simply to work on all levels directly and contribute together, right? So make the management level as lean as possible. That's the bottom line of it. Gain knowledge of hardware abstraction. The more we can gain there, the better our updates are running, right? So software packages in general needs to be distributed also within the car. Drop the B and A sample, which is virtualization, which means you don't have the hardware very early for your ECU project. And the last but not least, and this is more, be patient with software developers, because it is an effort. And if you cannot estimate the effort, ask someone to estimate it. Take defensive forecasting. Don't be bold. Things like automated driving is there in 3 years. Doesn't help anyone in the market right now, okay? So as a last task, I promised that, I would like to invite all the 3 presenters coming up one more time. Thank you. All right, so you can give a vote by hand raising, okay? Every one of you, and the game is called, whose quote is it? Okay. So the first quote is called, we plan, design, and develop 6 months less a whole production of a vehicle platform. Is it Atul? Steve? Or Nigel? Ah, there we go. So, yeah, I think that was the learning. We remember that. We accelerate the production side for the future. The second quote is, my scissors kick will impress you during my test automation run seamlessly. Is it Nigel? Steve? There you go. Thank you. And the last one, we utilize AI to accelerate data-driven automation in software-driven enterprise. Is it Steve? Atul? Thank you. Yes. So you listened to us. That's very helpful, and I hope we gave you a bit of power in the morning. So yeah, let's have a great day and also a nice presentation in the main hall. Thank you.